Good morning, everyone. So, as Shashank said, LC3, I did the first LCA for life cycle assessment for LC3, where we found out it saves about 30 to 40% carbon emissions. But I'm not going to talk about the history, but rather where, as GIZ, GIZ is a German organization. It's a fully owned entity of German government working in India for the past more than 60 years on the issues of sustainable development. And basically, we work with the Indian government under a bilateral cooperation between India and Germany. And for this particular project, we are collaborating with MOEFCC, and that's the way it is structured, the project is structured is that International Climate Initiative is a funding arm of German government, which is the Ministry of Environment, Climate Action, Nature Conservation and Nuclear Safety. So it is, ICI is the funding arm of that particular ministry in Germany, which has a collaboration now under a bilateral cooperation agreement with MOEFCC for this particular project titled Indo-German Support Project for Climate Action in India. And GIZ, being a German entity, is the implementing agency on behalf of German government in India to implement this project. So that is how politically this project is structured. And under this project, then we have a collaboration with IIT Delhi on LC3 commercial upscale in India as well as advanced research. So that is how we came to LC3, and that is how this whole project is politically structured. So I'll start why cement sector. Why did we even choose to work on cement sector under this project? There are various reasons for it. First is it's a hard to abate sector. India is the second largest producer of cement in the world, and it is also very, very important for India's development. So it becomes a very crucial sector to decarbonize. There are about many companies in India. I mean, Indian cement companies are one of the best in the world already in terms of sustainability over many, many years, and now they are pushing boundaries further. So it made sense for a German cooperation to work on a technology which was right there at the door of getting commercialized. But as Shashank said, as cement industry is very conservative, it was not just, it needed a little nudge. And that's the reason why we also chose this technology and chose this sector to support it to be commercialized. And it is also one of the priority sectors of Leadership Group for Industry Transition, which is a national program, which is Indian program in collaboration with in collaboration with Sweden, for which Ms. Ruchika Dral from MOEFCC would be talking about a bit more. So cement and steel are one of the priority sectors. So we also wanted to make sure that whatever we do under this bilateral cooperation between India and Germany on cement sector contributes to this national program of Government of India. We had an hypothesis. As we said, when we started working on LC3 along with IIT Delhi, it was already BIS certified. So what next? It was not getting, a lot of attention from the cement industry. There was no commercial production happening, even after the BIS certification happened. So our hypothesis was that after the BIS certification, since cement industry and construction industry is very conservative, if we showcase a commercial pilot with cement manufacturer and a cement user in a commercial environment, the acceptance of the cement in the market will enhance and it will lead to its upscale. That was the hypothesis that we started working with. And that's where our whole arrangement, and our, technical discussions with IIT Delhi started. But then road to getting the cement produced for the first time in the Indian subcontinent, this particular cement, was not easy because it is a new product. It is a new product for the Indian market. So not everybody knew about the cement, what the technology, what it does. So BIS certification, we realized that it was not enough. LC3, in the legal aspect of it, also needed a local nod from the local pollution control board. So wherever the LC3 is getting produced, state pollution control board has to okay it that if you're producing the LC3, is it increasing the pollution load in your cement production or it is not? If it is increasing, there is a separate way of getting it certified. If it is not, there is a separate way of getting it certified. Now to just explain that, in what conditions LC3 will increase the pollution load of the overall cement production, and that's why it might need an environmental impact assessment, or in what cases it will not lead to a pollution load, then it will need a no pollution load certificate. But for that to happen, we need to build capacities of local pollution control board. In this case, Rajasthan Pollution Control Board, because it was JK Cement that the Rajasthan plant was trying to produce this particular cement. So we met with local pollution control board several times trying to explain what the technology is, how does it reduces the cement, what it does. And with multiple rounds of capacity building, we were able to communicate to them so that they can make a decision that how, in what case we give an EIA, in what case we get an NPLC. So we build their capacities. So BIS certification was not enough to get it legally produced in a state, but rather pollution control board also needed a lot of capacity building. And now if this LC3 is getting produced in other states, probably same capacity building need to be happen, because they also need to know what is LC3 and what it does. The second was the user side of it. So also the producer side of it. We know cement companies know a lot about cement, even the users know a lot about cement, but LC3 again was a new cement. And as Shashank said, there is a team in India. LC3 is a made in India cement. About 80% of the research on LC3 happened in India. So we had the technical resources in India to help the cement industry as well as the users. When they are producing the cement and when they are using the cement, they needed on-ground support when they were producing this new cement. So that was the technical support provided by IIT Delhi and their team, and that was the support which was funded by this particular project so that we can make this happen. Then we also needed a regular dialogue with cement and construction sectors to showcase learning from the commercial pilot, and that's exactly what we are doing in this kind of workshops, more workshops that will follow, because as I said, that was the hypothesis. Once we made this commercial pilot a success, we would want to take it out to the cement industry and tell them that commercially this particular cement works, not just at the production side, but also at the use side. So at the very best, we have successfully tested this hypothesis in India. And that's why, as you see, Shashank said, showed you a picture of when they were preparing to produce the cement in JK Cement. This is a picture when the day the production happened for the first time in JK Cement. And we also worked, Shashank's team also worked with Lodha Group on their site, explaining their engineers how the cement would work in a real case scenario, what are the challenges that they were getting, and then solving their queries on a day-to-day basis. And that is a very important, technical support that was required. And we were glad that LC3 TRC was already set up here to make that happen. And we were glad that we were able to support this whole endeavor. And this road that you see is recently built in the Lodha, Palava city. So from the hypothesis of this particular cement getting commercially accepted, we have reached where now JK Cement, Lodha, and even Noida International Airport are now going out and announcing that we are now using this cement commercially in the market. But is it enough? Well, we don't think so it is enough, because for an upscale, in a country like India, which produces about 65 to 70 million tons of cement per year, we need LC3 to feature in the pie chart of the three cements which are out there, OPC, PPC, and PSC, significantly. And that's where we were able to make a dent in decarbonizing the whole cement sector. So from here, what we want is that cement industry knows more about this. They know that how this particular cement can be produced. They know how the cement can be used. And there is a more demand creation in the market. So that is where we now need to go with the technical support which is available in India, because as I said, it is a make in India cement. The second part, which I explained in the first slide, is the advanced research. This was the commercial pilot, and this is the advanced research. So we want to go a bit further. We wanted to first reduce the CO2 emissions from the production of LC3 at the first place. And there is a solar concentrated technology that we latched onto, that can we calcine the clay, which, as Shashank said, at 700 to 800 degrees Celsius using a solar technology. So there is a solar concentrated technology, which now IIT Delhi is now testing at a very lab and pilot scale to reach those temperatures, test if the clay can be calcined using that technology, and will it give the same properties as it has been calcined using non-renewable sources of energy. The second is we wanted to make the product offering made by LC3 a bit more wider. Can LC3 be used in harsh conditions, such as sewer lines and highly acidic or highly alkaline conditions out there? So we wanted to test particular those, for those use cases, we want to test LC3. So for that also, IIT has been conducting a lot of tests for the past 1.5 years under this particular arrangement with them. And we are very sure that there are some positive results that will come out, and the use case of LC3 will enhance. So these were the two barriers we wanted to also break, further reduce the CO2 emissions from LC3, and also enhance the use case so that the market acceptability and the market for LC3 becomes a bit more wider. The second thing that we are doing is that this is for the whole cement industry using LC3 as a case example. can we do a star rating for cements in the country? Can we have a methodology through which, a scientific methodology through which cements in India can be rated a 4-star, 3-star, 2-star? And that is the methodology that IIT Delhi's sustainability team under this project is particularly making, and we are almost there. We'll also share the results in some coming time. So right now, there is no particular star rating, a green star rating for the cement based on scientific data, based on scientific methodology. So that is what is getting developed. So these are the 3 or 4 new things that we were trying to do under this grant beyond the commercial pilot. So that is the whole work that now ensembles with IIT Delhi, and I hope that the cement market, which is out there, will take up the cement, and India will have a bit more cement LC3 being produced in the country, so that the decarbonization aspect of this particular industry is getting addressed using LC3. Thank you.